And hello everyone! Today we are back with a little bit more of programming in ComputerCraft. This is episode 8 of our series, and after the few more tutorial-like videos, I will come back to our mining script. At least that's the plan. And for as far as we have made progress in the past few episodes, is that we have made a pretty decent first version of our mining script. That one does function, it does go forward with a turtle, it does all the mining, and is quite robust what it needs to accomplish. And I think for today we can heavily improve on that. A few things I want to change today is first of all, I want to go through all the functions and add a little bit of comments, just some guidelines of what the function is doing, and also be a reference if I send this to someone else at some point, that they at least have an understanding of what is going on. For some functions that would not be exactly necessary, for example our refuel function, well, it's fairly clear what that is going to do. Well, who knows what I mean with height? It can be everything. Input, well, if you do it in this format, it's pretty clear what it is going to be. And distance, defined as input 1 in this context, does also work. But it's just a bit neater to do that. And I'm also looking to make this entire section, where the turtle moves and everything, to do that into a function of its own. And then it is quite handy to explain, for example, where the turtle is in the program, so you don't have to go through all the code every single time to know where you are. Some stuff is happening, or some stuff is just going not the way it should be. And after that, I will transport this file into our own API. Like we have seen, we have Turtle API, and another example, we have I think we have only dealt with Turtle API so far. There are many more, like we have seen in the tutorials. But it might be handy to have that as our own API, since then we can just call name of our API.refuel, and then we can remove this part of code, those few lines from our script. That way, make our actual mining script a bit neater, and above all, a bit more organized. So that's the plan for this episode, and maybe we will start into a next thing, which is sending and receiving information over the wireless network. So like I said, I will first add some comments. In Lua you are doing that by a double minus sign. In other languages it's a double slash or an asterisk sign. There is a way to multi-comment in Lua, but I rarely use it, to be honest. But this was the height for our turtle to go up and down. Height for turtle to go up and down. And within brackets, you can make that tunnel height. Height for tunnel. Just a bit more explanation. For input, given input in form of parameters. It's always a debate on how you actually write this, but I like to do it in this way. When program has been run. Okay, and input is the distance to mine according to input. I think that will be enough. Then we have functions. I always like to include that in the first line of the function. Some other people do it above the function. I think that is, well, that works, of course. It's commented. The comments aren't run by your program script thingy, in our case a turtle. So it all works. But I think it's handier to have it inside. For example, if you make it a bit smaller, then your comment is also away from your objective. If turtle fuel level is the row set level, then it will be fuel with the fuel in slot. I believe we chose 16 for that. For a function just forward, I don't think it's necessary to do it. Same is true for back, for up, down, dig up. And from all of this, I'm going to make a function on its own. And when we are going to move that into an API, we have to alter the names a bit. But the functionality, of course, will be the same. Function, and how shall we call it? Mine section. I don't think we need any input for that. And let's move all of those by one tap, so it makes it a bit easier to read. All operations to mine one slice of the to mine. So no, distance is going to be a weird thing in a moment, but we will fix that. I will make a second line. Oh, we don't need any other explanation for that. That's all that it is going to do. And like I mentioned, we will make this now for just for a slice in the API. So this can go out. Everything related to distance can go out. Just need to make that, well, put that back when we work on our new script. And we will have an end, well, one end too much in here. And now we only need to do something with the variables. Technically, you can make an API for your variables. Then it's not really a variable anymore, but more of a constant. That might actually be handy. Then you have a small config file to work from. I think we actually are going to do that. So let's make a file config. We're just going to save this and exit. And edit double P, I think. That's going to be our mining script. Let's open those two in. I'm actually going to make another one. Edit Brave. That's kind of what I always choose as an API name. Brave.something, that is a bit easy to type. But all our functions are going to be in our Brave file. Let's zoom that in a bit. And we said that height could be kind of a constant, so that can be into our config file. Just to make sure we can't set it as a local variable anymore, since that would be a bit weird to use that in certain places. So we still have a few variables to set at the beginning. That's fine. Before we do all of that, we are going to include our API. So we have os.load API in bracket, and we will input the path as a string, which isn't too difficult since it is just in the main folder where also this script will be. So that will be brave.lua, close brackets, and then from now on all our functions will be loaded. Let's include our config file as well. So that should be in there as well. And just to be sure, I'm going to print config.height. Just to check if everything works. Config.height. Everything should be working, but you never know. Height was 15, so I guess that's good. That does also mean that the Brave API is loaded, so now we can work from here and make life a little bit nicer. Like I mentioned, we need to kind of get our for loop back. Still a distant function or distant input we can work with. We need to convert that again, or check for if it is a number. And if it is the number, then we have to convert that. But I want to go back a little bit further than that and check if input is actually a table. So it is just making sure that everything is right in the way that we expect it to be. So we are going to make a function. Function check input. Let's do that always. Parameters. This is going to be an input. Let's use a table. And hopefully that's going to be a table. And if everything is alright, then we can use this function to spit out any kind of input that we had. For example, our distance as a number instead of a string and those kind of things. So that's what we are going to do. Now we are going to imagine that we have a table as an input. We just need to make sure that it is actually a table. So if type from table is equal to table, that is type of variable, then we are going to do some stuff. And if it isn't a table, then we won't do something. And actually, we can do that. Else return nil. Since then something has gone wrong, and we need to end the program kind of as quickly as we can. We can do that a little bit faster with the error, but that's a really hard error, which is kind of difficult to work with. At least in my opinion. So if it is a table, then we want it to check if table 1 equals the type of it. I actually want to make sure if there is something in it. And we actually want to do that for a few. We can better use a for loop here. For, let's set up a local variable. And why not? Use anything here. As long as it is local and equals 0. Wait, 1. No, I'm going to make another mistake. For n equals from 1 to the amount of slots that are in the table, which can be done by the hashtag. It's going to look for the length of a variable. In this case, how long the table is, how many objects are put into the table. To the bottom. And if table 1 is equal to nil, then return nil. So, and with that for loop, we do at least know that there is something. And now we are going to go a bit further than that. So now we are going to modify everything in here. And we do know that the first input usually comes as a string, and we need it as a number. We can do a few things. One is for every single parameter that we are going to make, set up an own variable for that, which is absolutely fine. We can do that without any problem. And then, in our case, to number to that variable and insert it into the table value. Might be a little bit too much to do it in that way. Now I think by myself, it doesn't really make too much sense to do it in that way. But still we want to make sure that to number actually did something. We need to make something for that. For example, if it doesn't work, then someone has typed something incorrectly, then it's still, well, it's still a table, of course, and the content isn't equal to a nil, but it's not a string that we can convert. Let's assume that it is possible to set it to a different variable. To number table 1, and let's check now if it is indeed a number. If type of table 1 equals number, then if it is not equal to a number, that's better, I think. If it is a number, then everything is fine. Return. Yeah. Something went wrong. And for now, there's no other variable in here, so there should only be one thing. And if everything went all right, then it will return table. I think it must be something like this. Which is kind of, now I think of it, is kind of our setup loop, as you might know it from different projects I think of an Arduino. It's just making sure that stuff, well, works the way it should be. Brave.check parameters from input. That will be our test table. Let's see if this will run at all. We did make some problems. Attempt to get length of nil. So we did already make a mess of it. On number 4. Get length of nil. Oh, I made a typo. Let's see. Let's save, of course, what this is going to do. And with that, I think we made just enough progress for this episode. So we went from one big filled piece of code with just functions and one loop, several APIs, one config API from where we can get our distance. That luckily works. And we have our Brave API with all our functions and with now a few more checks if stuff is actually working. So in our next episode we will be working with more checking if stuff works and polish our API a bit more and get our turtle moving again. So that's it for this episode. I hope you have learned something from it, and I will see you in the next part. Have fun and bye bye.